Hey girls and boys, it's Mr. McAndrew, the math coach. Really good to be with you. How are you doing? I hope it's going well. So last time we were together, we were doing some factors and multiples. This week we're going to focus on area and perimeter, which should be something that you already have a fair amount of knowledge about. In fourth grade, the standard for area and perimeter is, to take what you already know about it and to apply it to some more like different types of real world situations, which we'll be taking a look at. Okay? But let's begin with what you probably already know about perimeter. So we'll do a quick review and then we'll get into doing some more fun activities. All right? Sound like a plan? All right, here we go. So here's a real basic example of area. So remember that the area, right, if I just move this out of the way for a minute, if I were to just draw a rectangle, right, the area of this rectangle is how much space is inside of it, okay, all of this space right here, all right, and typically the way we measure the area, at least of rectangles or squares are just special types of rectangles. The way we measure it is using square units. Okay, so if I let me just erase that real quick. So if I draw that again, we would say how many square, like centimeters, right, might fit in here. So it might be something like this, right? So how many square units, right? So we can see in this example that we have 1, 2, 3, 4, 5. That's 5 here. And that's 1, 2, 3, 4, and that's 6. So that's 5 rows of 6, right? Or 5 times 6 equals 30. So the area of this rectangle is 30 square units. Or if they were centimeters, we say centimeters. Okay? So that's just a review, right? Now the perimeter of a rectangle is the distance all the way around the outside. The perimeter of a rectangle or any shape whatsoever. So if I were to start here and I were to go and then come down here and then come across here and then up here and I measured that, that would be the perimeter. So if this is 6 and this is, then this side must be 6. And if this side's 5, then this side must be 5. So we have 6 plus 5 plus 6 more plus 5 more, and if I add up all the sides, that would give me the perimeter. And that would be, 24 centimeters. Because, no, wait, that's not right. 22 centimeters. I'm sorry, 22 centimeters. Silly, but this is why you need to check your work, right? Because you can make mistakes. So 6 plus 5 is 11, plus 6 more is 17, plus 5 is 22. Okay, so that's perimeter. So if we look at the shape that I've already made, right, with these square inch tiles, right, what's the perimeter of this rectangle? Take a look. Ooh, what's the perimeter of this rectangle? Perimeter and area. So the area would be how many square inches, right? So how many square inch tiles are in this rectangle? What's the area of it? So how much space does it take up? So it looks like it takes up 1, 2, 3, 4, 5. So there's 6 here, and there's 6 here, and 6 here. So 3 rows of 6. So this right here, this would be like my width is 3, and my length is 6. And if I multiply the width times the length, right, because I have 3 rows of 6, I will get the area, which is 18 square inches. Okay, each one of these is a square inch. Okay, so what would be the perimeter, the distance around the outside? What would that be? We know that the area equals 18 square inches. What would be the perimeter? Anybody have a guess? Let's take a look. So if this is 3 and this is 6, then this must also be 3 and this must also be 6. So if we add those up, excuse me, if we add those up, we get 6 plus 3 is 9, and then 6 plus 3 over here is also 9. 9 plus 9 is also 18. That's interesting. The perimeter and the area are the same. So, but we write it differently. The perimeter would just be 18 inches, not square inches, because we're not using squares to go around the outside. We're just measuring distance, right? It's just 6 inches, 3 inches, 6 inches, 3 inches. Okay? The other way that you have seen area is, of course, when you multiply, right? So if you were to have a problem like let's just take a simple problem like 13 times 4, okay, then the way you've seen it is if your width is, let's say, 4, okay, then, and this is 13, we break up the 13 by place value into the tens place, which is 10. Can you see that? Okay, yeah, okay. So I'll make this, right? So it would be, let's get rid of this. So this would be, we'll break up the 13 into 10 and 3, right? So here would be the area of 4 times 10, right? Which is 40 square units. And here we would do 4 times 3, which is 12 square units. So we would do 40 plus 12 equals 52. The area would be, the area would be 52 square units, right? So 13 times 4 is 52. Okay, so this is another, you've been using this in math a lot. Okay, so area we've been doing a lot with. Perimeter, you might remember, it was probably a few months ago I had you do you remember the time I had you guys measure using a tape measure around the outside of one of the rooms in your house, and then you added it up and you found the perimeter. We were practicing addition at that point, I believe, but that was another example of perimeter, right? Fences are a great example of perimeter because a fence goes around the outside of something. Okay, so what I would like you to do is take out this paper. Oops, you can't see it, hold on. It's in your math packet. It says area and perimeter reference sheet. We're going to fill in part of that right now based on what we just talked about, and then we're going to do some problems. All right, so grab that and then come on back when you're ready. We're going to write down a few things here. You can use this as a reference sheet. Okay, that's what it's designed for. And this is, again, boys and girls, this is just about rectangles, not like circles, okay, or just oddly shaped, shapes, right? Like this, we're just talking about rectangles right now. But one thing, the first one we're going to say is that area, okay, so you want to write this down, area equals length times width, okay? Or, and then I also want you to write down A equals L times W. Okay, so a formula in math is something that always works. And oftentimes we use letters to express it. So in this case, we have A, area, is the same as if you multiply the length times the width. And let's do a little tiny example here. We'll do, I don't know, let's do like 5 and 3, right? And then we'll do, inside we'll put A equals 15 square units. We'll put a U for units. Okay, so area equals the length times the width. In this case, 3, which would be like 3 rows of 5. Okay? We're going to fill in numbers 2 and 3 the next time we meet. For perimeter, I'll do that in a different color. We're going to say that the perimeter, and we actually just did an example of it, right? What would be the formula for perimeter? How do you always find the perimeter of a rectangle? What do you always do? That's the question, right? You always, like a formula has to work all the time. Not sometimes, like all the time. So we always have to add up, right? The length and the width, and then the length again, and then the width again. So the width gets added twice, and the length gets added twice, right? So we would write, for that, we could write down perimeter formula. So we can write down perimeter equals, we're going to put down length plus W plus W. And you know that L means length and W means width. Okay, and that perimeter, we're just going to put a little parentheses, can stand for P. All right, so if you add up the length, and this is, again, this is just for rectangles, okay? If you add up the length twice and the width twice, you'll always get the perimeter of a rectangle. Okay, so let's do something a little bit more fun here, okay? So check this out. By the way, boys and girls, there's going to be 2 videos today, all right? 2 videos, 2 for the price of 1. Lucky you, lucky you. Here we go. All right, so boys and girls, earlier I told you that we're going to be applying these formulas to like real world situations. Well, what we're about to do is absolutely not real world, but it kind of simulates it. So let me show you what I mean. When I used to teach 4th grade, we used to do this unit on area and perimeter, and we used this imaginary world called Antopolis, where you'll never believe ants live. Okay, so here's a couple pictures of it. I was just showing you. So here's a couple ants. They look like they must be like engineers or something. And there's a helicopter. And do you know what it's called when a helicopter has to land on something? It's called I'll tell you, it's called a helipad. 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 Or it might be helipad. I'm not really sure. It's not my thing. But I think it's a helipad. So, you know, a plane lands on a runway, right? But a helicopter lands on a helipad. We'll call it a helipad. Sure, let's just do that. Here's a picture of an ant flying the helicopter. They're very small, right? Because these are ants. These are not regular-sized, helicopters, okay? So this is just a little background to help you figure out what we're going to be doing next. So let me show you what's next. All right, so boys and girls, in your math packet, you have something that says Monday Practice with Mr. McAndrew, and it looks like this. It has a bunch of grid paper on it. So please take that out, okay? I'm going to explain what we're going to be doing, and then you're going to work on it. And then in the next video, we'll go over it, okay? So take that out and then come on back. All right, so I'm going to read it, and then we're going to discuss it, okay? So it says, this will be done with Mr. McAndrew, that is moi, during his video. That is right now. Help the ants of Antopolis find the largest helipad, however you say that, possible if they have only 20 centimeters of lights to go around the perimeter of their helipad. Okay, so for example, if this was their helipad, right, then that would be, this is 2, and this is 3, and this is 2, and this is 3. So that's 2 plus 3 is 5, plus 2 is 7. So that would only be 10 centimeters of lights. You need lights to go around the helipad. You know why? Because it's almost like Christmas lights, right? Because at nighttime, you need to see where the helipad is. Otherwise, you won't see it. Just like runways, airport runways have big lights, okay? All right, so, but it has to be 20 centimeters, not 10. All right, so we have to find as many rectangles as we can with a perimeter, right, of 20 centimeters, because that's all we have. That's the length, that's the greatest length of lights that we have, that the ants have. And then we want to find the biggest one possible. Okay, so let me show you one example, and then you try to find some more. What if my helipad has a width of 2, right? Then how does the length have to be, or the width, to make the perimeter 20? So you gotta think this through. You might make some mistakes. So for example, if I went down here, that's 1, 2, 3, 4, 5. So 5 and 5 would make 10, plus 2 and 2 would make only 14. So let's make it bigger. So now it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 and 2. So 2 plus 8 is 10. If I double 10, that does give me 20. Let's see if that works. Let me label this now. So my video is going to end soon, so I'll see you on the next video. But you can see that that works. 8 plus 8 is 16, plus 2 is 18, plus 2 is 20. So why don't you try and find a few right now, and I'll see you in a few minutes on the other.